I don't change what it's made of. I don't change the stuff it's made of. I don't change the matter that this paper is made of. Through science, we've discovered, yes, we can change things physically, but we can also change things chemically. So let's show you a chemical change. I need to put on my safety glasses. I need to get a match. And I'm going to try to change this paper chemically. Blow that out, let that go a little bit, and I'll blow this out. So we've zoomed in so you can take a closer look at what we're left with. And what are we left with? We have all of this stuff that started out like this white paper, but it changed chemically. It's no longer that white paper. It's black and charred, and even the match head is different too. That's because it's changed chemically. One of the clues that a chemical change has taken place is that a new substance is created. We could see that new substance when we burn the paper, but sometimes we can't see that new substance. Sometimes that new substance is invisible and just goes into the air. Well, today we're going to try and take a closer look at that invisible substance that can be created in a chemical change. A lot of times when you hear chemical change, you think explosions and fire. But chemical changes happen around us all the time, and we may not even think about it. Take, for example, this piece of bread. So we've zoomed in, and what do you notice? Well, I notice all these open spaces, these little pockets. Some are small here, but this one's big. Well, where did those come from? All of these air pockets were caused by a chemical change. When I mixed all of the ingredients together to make this bread, a new substance was created. So why does bread rise when you mix all the ingredients together? Well, that's because a chemical change is taking place. All the ingredients mixed.
Yes, mister? Mr.
Abdul Mohsen, how can we make bread?
Flour,
Yeah.
wheat,
It's
milk.
already the same. Milk, okay.
maybe sugar.
With water and sugar, and then put them all in
No,
the oven. In the oven, right. Then
Mister,
after a
but I
while,
only
you'll...
wanted to raise my hand to answer in the main questions.
Okay,
Not
so
the YouTube.
after that, we can get it like a bread after maybe 15 minutes, right? So it's
Yes.
a chemical change. Why it's chemical change?
Because we actually didn't change the shape only. We also changed the matter. It isn't paper. Like if we burn the paper,
It's
and
not in its
turn it to
origin
ash,
form. It's not in its
and
origin
that
form.
black powder is not a paper. It's ash, a new substance, a new matter.
That's right. Thank you. Yes, Ahmed.
Mister,
Yes,
can I answer?
you can answer. Why, when we burn the wood, it's a chemical change, not physical change?
Because it's burning. No, because we're cutting it.
No, it's
It didn't change. We just changed the form. We didn't we didn't burn it. We just cutted it.
no. I'm talking about burn the wood.
It's chemical change.
Chemical. It's reversible or reversible?
Irreversible. Because
Irreversible.
we can't. But Mister,
Yes.
I want to do something. Wait, listen.
Ahmed, please concentrate.
Mixed together and a new substance is created. That new substance is carbon dioxide gas. One of the ingredients in bread that's responsible for that chemical change taking place is a living thing. I'm going to pour some of it out. Right there. What is that? We've zoomed in so that you can see a pile of yeast. And believe it or not, this yeast is alive, but it needs the right conditions so that it can grow. So here's our yeast, and we have warm water and sugar. The warm water and sugar are going to give us the right conditions for the yeast to grow, and we're going to see if we can capture the new substance that's created when a chemical change takes place. Now I'm going to put a couple scoops of sugar into the water, stir it up, You can see I'm a little messy. That's okay.
To all of you, you have to do this experiment in your home, then take a video for it, send that to me. Focus, please.
Okay. And while
That's baking soda with vinegar.
that's dissolving, I'm going to dump some yeast into my bottle using my funnel. So I have the two things I want to mix together. I have my yeast and I have my warm sugar water. And I have a balloon that I want to put on top of my bottle so that I can capture the carbon dioxide that's given off because of our chemical change. So here we go. Let's dump some of our warm sugar water in. That's good enough. Let's take my balloon, really stretch it over the top. I want to get my balloon down as far as I can on the bottle, and I'm going to use a rubber band just to make sure it stays on top of the bottle. So I'm going to swirl it around just to mix things up, and it doesn't really look like anything's happening, but that's okay. This chemical change is slow. It takes time. It's kind of like watching bread rise. It's important to keep in mind that chemical changes can happen slow or fast. In this case, the new substance being created is carbon dioxide gas, and you can see it's not happening that quickly at all. So why don't we try and mix two different things together to create a chemical change which also creates carbon dioxide gas, but this is going to happen much more quickly. The two things we're going to mix together to make this fast chemical change is vinegar and baking soda. So I need to put my safety glasses on. And this chemical change happens so quickly, we're going to have to slow it down or delay it a little bit by putting the baking soda in a tissue and then dropping it into the vinegar. If we didn't do that, as soon as the baking soda mixes with the vinegar, we'd have a really fast chemical change, a new substance would be created, and we'd have a big mess on our hands. So I'm going to take a tissue, and most tissues actually have two layers of tissue that I can separate. I pull the tissue apart, and now I have a nice thin layer of tissue. I take my baking soda, put a healthy amount of baking soda on my tissue, and now I just bundle it up, take a twist tie, and I have a package of baking soda. Open the vinegar, pour some into the baggie. All right, so I'm ready to go. Now, just before I drop in the baking soda into the baggie, we're going to zoom in so you can take a closer look at what's happening. All right, let's drop it in. Now we have to make sure the baggie gets sealed completely. So I'm going to take my time and press. And I can, if I look, I can see the chemical change is already starting. I see some fizzing, some bubbling. Well, those bubbles are carbon dioxide gas. Remember, a chemical change, something new is created.
Manaf? Why you can see some bubbles here in the vinegar? When you put the baking soda with vinegar, put them all in one case, like as you see here. Then after a while, after 1 minute exactly, we can see some bubbles. Why? It's because of chemical change. Chemical?
Created, a new substance is created, and in this case it's carbon dioxide gas. Same carbon dioxide gas that is created with the yeast and the sugar water. It's happening a little slowly because the vinegar is seeping in through the tissue, and now what should happen, that new carbon dioxide gas should start to fill the baggie. If I want to speed it up a little bit, I can shake it. And we can see the baggie's going to start to fill up. I wonder what will happen if enough carbon dioxide gas is created to plump the baggie up. What do you think's going to happen? The baggie's looking pretty full.
Oh,
So did you hear that pop? What was the pop? Well,
look, Walif, what happened?
The bag pop.
That's right. That's because of the chemical reaction. The chemical reaction, right?
Yes.
Okay. Yusuf Hazem, how are you? Welcome back.
Fine, thank you.
Are you okay now?
Yes.
Okay.
Remember, the baking soda was mixing with the vinegar to create a chemical change, and in a chemical change, something new is created. In this case, it was carbon dioxide gas. And so much carbon dioxide gas was created inside the baggie couldn't keep itself closed. The air forced its way out, popping out of the bag. Remember, carbon dioxide gas, hey, we actually have something happening here, but remember, it's slowly happening. Here, it was much more quickly. So we've turned the overhead lights off a little bit so we can better see what's going on inside of our bottle. But take a look at our balloon. Remember when we first poured in the sugar water into the yeast, nothing really seemed to happen, but our balloon's a lot bigger. What does that mean? It means all of this carbon dioxide gas, because of a chemical change, is being created, and it's filling our balloon, and you can see it's filled our bottle. And take a look at the bottle. We've zoomed in so you can really see this up close, but take a look. The tiny bubbles in the bottle of carbon dioxide gas look very similar to these tiny little craters or holes in the bread. That's because that's what made all of these little pockets in the bread. Carbon dioxide gas from the chemical change of yeast reacting with the sugar. It's important to remember that chemical changes are happening around us all the time. Do you remember how we said yeast is a living thing? Well, we're a living thing, and chemical changes are happening inside of us all the time. If you want to learn more about chemical changes in living things, check out our links in the video description.
Okay, thank you for listening. Now please open page 408 in your science book. 408 in your science book. Yes, yes.
Mr.
Yes, Mu'taz.
I have a question.
Yes.
Why? How they? Why? How like the carbon dioxide came?
It's from the chemical reaction. We put baking soda with vinegar. You can try this experiment in your home.
Okay. Do I try it right now?
No, you can try it later, then take a picture or take a video, then send it to me.
I really want to try it right now.
Yes, but don't drink it, just to try it.
Yeah, I want to drink it because I'm so thirsty.
You can also try it with balloon.
I think the
Mister,
balloon.
how about after we do it, the experiment of the balloon, we make a bread in a bottle?
I think
You can do it.
Yeah, bread in a bottle.
and here.
Okay, thank you. Now please open page 408. Thank you, Alif. Thank you. 408. Chemical changes. If you cut a candle wick, it's still a wick. What happens if you light it with match? It burns and gives off smoke. The smoke wasn't there before. It is a new substance. Ahmed Mahjoub.
Yes.
Ahmed, can you please read from
Yes.
this part, all substances?
Okay. For where?
Yes, all substances. Read it.
Okay. All substances, including candle wicks, have chemical properties.
Properties, right?
These chemical properties determine how
Determine how substances
substance interact. These
Yes, go on.
interaction lead to chemical changes. A chemical change takes place when
A substance
change into an entirely new substance. Blow out a lit candle and look at its wick. The wick
is black.
not the same substance it was before it was lit. Burning w- has caused a chemical change.
Yes. Simply when we get a candle, when we try to burn it, to light it, look at the thread inside the wick, inside the candle. What its color? It's white, right? White. But after burning, it will change to be
It's
what?
gonna be black.
Yeah, so it's chemically change, chemical reaction, chemically change the same time. It's irreversible. We can change this wick to be white again after burning. Wow, look at this car. This car has changed. Why, Ahmed? Ahmed, are you with me? Okay. Abdullah?
Yes.
Abdullah, why we can see some rust on this car, the iron? Do you think that we leave this car, we left it for a short time or long time?
Long time.
For a long time. So this car has changed. Its glass is broken and its metal is bent. These are physical changes. But what chemical changes have taken place? The chemical change here, like what?
Rust.
Like rust. Read this part, please. Rust?
What is red brown stuff on the car? It is rust. The paint has peeled off, exposing the car metal frame. Over time, the metal
Reacted comes from reaction.
with oxygen to form
Rust.
rust.
That's right. The next page. 409. Use Foda. Where do the materials do make new substances come from?
Okay, 409. Okay. Where do the materials to make new substances come from? They were there all along. Look again at the car. Existing matter, oxygen and iron combined chemically to form a new substance. Rust,
Yeah.
no matter was created. This means that the same amount of matter or mass is pretty before and after
Is present.
substances
Wait. Is present.
is present before and after substances reacts. Scientists
Express this idea.
this idea by saying that mass is conserved during a chemical change. Sometimes
Wait. Thank you, Yusuf. Thank you. Okay. Walif. Sometimes read, please.
Sometimes a chemical change results in products
And product.
that are hard to see. When wood burns, smoke blows away, and invisible gases
Are given up.
give it off. Even so, if you could collect the determine the mass of all the products